Today I am going to explain first chapter in physics, electricity. So what is this electricity? We know that electricity plays very important role in a modern days because it is a controllable and convenient form of energy because of its various uses in house or in schools, hospitals or in industries. So what is this electricity called? Electricity is a form of energy. You know that there are different forms of energies are there. Light, sound, sun is a source of all energies. So in this, electricity is also called as a form of energy. Anything to call it as an energy, it has to satisfy two laws of energies. That is, it must have capacity to do the work, then only we call it as an energy. Electricity has a capacity to do the work and it is easily transformed to other forms of energy. Electrical energy can be converted into heat energy. Example, electric heater. In that, if you give the electricity, it is converted into heat energy. Electric iron box. And electrical energy can be converted into light energy. Example, tube light. So, an electrical energy can be converted into sound energy. So, it is easily converted into other forms of energy. Therefore, it is called as electricity is a form of energy. So, what does this electricity constitute? How does electric current flows from one point to another? You know that in houses, switch will be there in one place and this is connected to the electric light. How the current flows from switch to the light, or if you have taken a torch also, the cells will be connected. If you on the switch only, the torch will glow the light. How the current will pass from the cells to the light. So what does it constitute? What are the factors that regulate this electricity? That all will study in this chapter. The mean electric current is due to the flow of charges. Electric charges will call. So what is this charge means? It is the physical property of the matter that causes it to experience the force when placed in an electromagnetic field. So charges are present in a matter. So there are two types of charges are there. Positive charge and negative charge. So if you study in an atom, so subatomic particles will call, that is protons, neutrons and electrons. These protons are called as positively charged particles and negatively charged particles are called electrons. These are the subatomic particles. So these subatomic particles will carry the charges from one place to other. This move of electrons, we consider the move of electrons on negatively charged particle constitute an electric current. So this charges are measured, the SI unit of charge is called coulomb. So symbol is C. This charge is equal to the equivalent to the charge contained in a nearly 6 into 10 to the power of 18 electron. So 1 coulomb of charge contains 6 into 10 to the power of 18 electron. And 1 electron constitutes 1.6 into 10 to the power of minus 19 coulomb. So what are these properties of charges? There are two types of charges are there. One of positive charge. Positively charged particles are called as protons and negatively charged particles are called as electrons. The properties of charges are like charges repel each other and unlike charges attract each other. So you have studied the properties of magnet. Like poles repel each other, unlike poles attract each other. So the same properties that charges will be having. So this negatively charged particles, electrons will be moving from one place to another in a conductor. What do you mean by conductor? Conductor means the metals are classified into two groups, conductors and insulators. So conductors means which allow these electrons to move are called it as a conductors, which allow the electrons to move or which allow the current to pass through them are called as conductors. So examples are metal. Copper is called it as a good conductor of electricity. Aluminium. So that are all called it as conductors. And insulators, which does not allow the current to pass through them, are called it as a insulators. Example, you can take glass or wood, plastic are called it as insulators. So the flow of these electrons in a conductor, in a metallic wire if you have taken, the electrons will move. So that flow of electrons will carry the charges. The how much amount of charge flowing through a particular area in unit time. In a conducting wire if we have taken, so how many charges will flow in a particular area, but in a particular time if you have taken, that constitutes an electric current. This is the definition of electric current, or simply we can define it as the rate of flow of charges is called as electric current. What do you mean by rate? Rate means per time. Okay, and how much charges flowing per time is called as electric current. Electric current is denoted by I is equal to charge Q divided by time T. So that is formula to find electric current. Electric current is equal to Q by T. In these three quantities are there. If they are given any two quantities, another one you can find out. If they are given charges and time, you can find out current, or you can time if they are given. So this is a formula to find the current. And the SI unit of this current is ampere. So it is denoted by capital letter A. So what do you mean by 1 ampere? When we call it as a current of 1 ampere. 1 ampere is constituted by the flow of 1 coulomb of charge per 1 second. If 1 coulomb of charges flows for 1 second, then we call it as 1 ampere of current is used. So it is a small quantities of current also expressed in milliampere, that means 10 to the power of -3, and then microampere 10 to the power of -6 also will be used. How will measure the electric current? Which is the instrument used to measure this electric current? Means the instrument used to measure electric current is ammeter. Ammeter is used to measure the electric current. It is showing 1 ampere we are used, 2 ampere or 3 ampere like that. It is used in an electric circuit to measure the electric current. Then electric circuit. So what do you mean by circuit? Means a closed path along which electric current flows is called electric circuit. A closed path in which electric current will flows. Okay. So electric current flows means electric electrons will be moving. The flow of electrons is constituted an electric current. So here a simple circuit we have taken here. A battery, wire, conducting wire, copper wire or aluminium wire you can take, switch and a bulb. So you can make the simple circuit. How this current from the chemical reaction will undergo in the battery, it gives an electrons to move to the move along the copper wire and the light will be glow. So this is called as an electric circuit. So what components were used in an electric circuit are represented by the symbols. So this is a battery symbol and copper wire. So these are the symbols used in the components of electric circuit diagram. Connecting wire. The wire is conducting wire means just a line drawn. If 2 or 3 wires if you join means, so wire is joined. This represents wire is joined. Cell, it contains a positive terminal and a negative terminal. Positive terminal should be lengthier than the negative terminal. Battery, a combination of 2 or more cells is called it as a battery. Then ammeter, an instrument used to measure the electric current. Then voltmeter, it is an instrument used to measure the potential difference. Galvanometer, it is used to measure the current in a circuit, whether the current is there or not can be found out by the galvanometer. Electric bulb symbol and the resistance, these are the terms related. Next we will study about this voltmeter and resistance. And open switch, okay, or you can write like this, or a closed switch, so that can be represented. So by using that symbols, we will draw the circuit diagram now. So battery, can you recognize which one all the symbols I have used? Conducting wire, bulb, so you can write this symbol also, and in that symbol it is that also you can write. This is switch. So this is a simple electric circuit. Next, the terms related to this. See, in a horizontal tube if you have taken, does the water flows from one end to another? If you have taken the tube like this horizontally and hold and fill the water, in which direction the water will flow? So if you, in a equally it is there, means water does not flow in any direction. If you maintain the higher level in any one side like this, then the water will flow from higher level to lower level. Like that, to move the electrons, I told moving of electrons only constitute the electric current. Now, how the electrons will be moved from one end to another end of the conducting wire or this conducting wire. So, they have to maintain a potential difference across the ends of the conductor. So, what does this potential difference means? Electrons move easily when there is a difference in an electric pressure is called as an electric potential. This electric potential is done or produced by the battery. That's why we are using a battery in an electric circuit. If this is maintained, this electric cell or a battery maintain the potential difference, that means at the one end of the conducting wire there will be a rich in electrons, and another end of the conducting wire there will be a very less in the electrons. Then electrons move from the higher level to the lower level. Electron rich area to electron less area they will be moving it. So that is called it as a potential difference. Potential difference is defined as the work done to move unit positive charge from one point to another. To move this electron, so the moving means the work has to be done. So from one point to unit positive charge if you have taken from one point to another, that is called as potential difference, equal to work done divided by charge. That is B is equal to W by Q. Is called as a potential difference. So the SI unit of this potential difference is volt. When we call this 1 volt, we define 1 volt. 1 volt means potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to another. That means unit quantities if you have taken, then you will get a unit. 1 volt means 1 joule. SI unit of work is joule and SI unit of charge, that is coulomb. 1 joule per 1 coulomb constituted 1 volt. The instrument used to measure this potential difference is voltmeter. Thank you.